In the second video for Module 20, we consider deposition and coastal landform types. When we think about deposition, sand is the best example of a depositional material. We know that deposition happens after erosion, so you have to remove it from somewhere, and then transportation, transport it. So where materials are left behind, we refer to that as deposition. And we know that sand particles, if you look at them up close, they look a lot like river rock. So those sand particles have been hitting each other over time as they're washed up and washed back down beaches. So the particles are often rounded by this process of abrasion. Not all depositional materials, though, are sand. We find a real variety of different kinds of beaches, like this beach with pebbles, and even this glass beach in California that was created by trash. If you look at materials that make up beaches, on the south coast of Iceland, we have some beaches made up of volcanic materials, so the beaches are very dark in color. And elsewhere, materials in the rock that eroded to become sand give the sand a unique color. So this green sand in Hawaii was created with some mineral that was included in the formation of the rock. And we have very red sands in the Galapagos, formed by the oxidation of iron-rich lava deposits, and some shell beaches in Australia. So let's talk a little bit about coastal deposition and look at some of these features. So the beach is the most common depositional landform that we find, and the best known. But there are others, including offshore bars. An offshore bar is where you might find sand existing, but not connected to the shoreline. Sometimes these offshore bars are underwater, and we'll talk about those and some of the hazards caused by offshore underwater bars. And then spits, where sand is carried out and carried past the edge of the coastline by longshore drift, that we talked about a little bit in the last video. Let's talk about some problems with underwater sandbars. Maybe you've heard of this, the riptide or rip current. So what is a riptide or rip current? Well, it's a situation where you have an underwater sandbar, one that's not even necessarily visible from the shoreline. And what happens is waves will come over these underwater sandbars. So in their normal process, they'll just pass over these things. But when the water recedes, the water is channeled between the underwater sandbars. So you have what's called the rip current, where water moves between those two underwater sandbars through what's called the neck. And that can be a real problem for swimmers. So if you're caught in the rip current, the first tendency might be to swim back to shore. But if you do that, you can become very tired. The way to escape one of these rip currents is to swim to the side before you try to swim back to shore. And here's another rip current that you can see from above. It's very difficult to see these from the beach level. Let's talk for just a moment about landscapes influenced by sea level change, since we've talked about sea level change as being something that's important in coastal landform development. And I want to kind of walk you through some landscapes that are associated with either rising sea levels, like shorelines of submergence, or emerging coastlines, as in the case of shorelines of emergence. So let's start with shorelines of submergence, and we'll look at this situation that we call a Rhea coastline. So imagine in the upper diagram you have a coastline that's here a little bit away from these coastal mountains, and sea levels begin to rise and fill and cover the flat low-lying areas, and the ocean levels or the ocean waters begin to sort of move up those former mountain valleys. We refer to those former mountain valleys as Rheas or drowned valleys, and the headland becomes much more complicated. Show an example of a Rhea coastline. This one's in Japan. So again, this was formed by rising water levels. Another one that's pretty well known is Chesapeake Bay, another Rhea coastline. And I've sort of added this photo so you can imagine what parts of Chesapeake Bay might have looked like 18,000 years ago when water levels were much lower. So with the melting of glaciers coming out of the last ice age, some of these river valleys have been drowned, and now they look like this. So this is Chesapeake Bay today. We have other areas that instead of going through submergence have actually gone through a process of emergence, where the land surface has risen. So the whole land surface has emerged or risen a little bit. And here in this place in New Zealand, you can see some former shorelines, several former shorelines where water levels were higher at one time, and this whole area was uplifted, was pulled upward. Another example that is a little closer to home for me are the marine terraces on San Clemente Island. San Clemente Island I showed here in this map in the lower right-hand corner of the slide, but you see it's an island that's a little farther out than a better-known island called Santa Catalina Island. Santa Catalina Island is one you can visit, especially the town of Avalon. San Clemente Island, shown in the photograph, is not one that's really open to the public. It's used as a bombardment site by the Navy. But you can see several former coastlines here, and these former areas where the coast was are referred to, or I shouldn't say referred to, create what are called marine terraces. So here we have a lower marine terrace and a couple of other marine terraces that represent the shoreline at different points in time. Compound shorelines are shorelines that have experienced both submergence and emergence. In this area, West Sussex in the United Kingdom is one example. You can sort of see a little bit of a raised beach, a beach that's been pushed upward a little bit, uplifted. But compound shorelines are pretty unusual in that they have experienced both submergence and emergence in recent geologic history. And then finally, neutral shorelines are areas that have experienced neither submergence or emergence. And some examples, deltas and coral reef areas. Deltas are evidence that a shoreline has not experienced emergence or submergence, because if you had submergence, the delta sands would disappear and emergence would expose more land. So they sort of provide evidence of a shoreline that's fairly stable. And the same thing with coral reefs. In order for coral to grow, it has to be at a certain depth, a certain temperature, a certain amount of light that would support the plant life that actually feeds the coral that's found in the water. So if the water level rose, the coral wouldn't be able to survive, and certainly if the water level dropped, the coral would not be able to survive either. Okay, some coastal landform types. I just kind of want to walk through sort of a little bit of a tour of coastal landform types. This one, cliff bench terrace, is associated with shorelines of emergence. Again, you can see the former coastline here and a couple of marine terraces. So cliff bench terrace is a kind of neat place to see. Here's some examples of some features associated with cliff bench terrace. We talked about headlands and these shallow bay areas where you'd find beaches. The sea stack is something associated. That's a place where the coastline extended out at a previous time. We also find sea arches. They look a little bit like arches that you'd find in dryland areas, but they're created by waves. And sea caves as well, also created by waves. Here's a sea arch. So heavy wave action created the sea arch, kind of provided, sort of undermined this rock here that might be slightly softer rock or more easily eroded. So these things are pretty spectacular when you get to see them. Sea stacks are land separated from the coastline. So the erosion sort of pushed back the coastline and left behind this remnant of where the coastline was at some time in the past. Just to show you the speed at which sea stacks can erode over time, here's sort of a kind of a time-lapse view, if you will. This is a sea stack back in 1890, and you can see that this is the same place. There's a lighthouse you can see sort of in the top left on that off in the distance. So just for perspective, and here's 1910, and the sea stack eroding pretty significantly over this 20-year period. So the sea stack is still there, but has been eroded down. 1920, it's a little bit smaller, and then it's almost completely gone by 1990. You see it, just a few remnants of rocks there. So give you some idea of how long it takes for this coastal erosion to happen. And it really is pretty location dependent. Some other cliff bench terrace features. Sea caves are pretty unusual and pretty amazing when you find them, also created by wave action. Painted Cave is the largest sea cave in the world. It's on Santa Cruz Island off the coast of California. It was actually used by smugglers during the Prohibition years in the 1920s. They would bring liquor up to the Southern California coastline from Mexico, and then they would sort of shuttle it back and forth to cities like Oxnard, and they would use these sea caves as a staging place for storing that liquor so it wouldn't be discovered by authorities. And here's what it looks like inside that sea cave. You could actually put a sailboat inside this cave with a giant mast, and there would be plenty of room to spare. So it's a pretty big place. Here's another view inside that same sea cave on Santa Cruz Island. These griot or inlets created by wave action are another sort of typical feature associated with cliff bench terrace. And then also the blowhole. Blowholes are sort of unusual. They look like, when you're standing by them, they look like geysers, but they're created by waves. So you have wave action where water is pushed into a hole that's under the water level, and that increases pressure, and that pressure pushes the water out of the blowhole. A couple of other features that I wanted to mention. Bar Lagoon. Bar Lagoon is created where longshore drift may just spread sand over an inlet and cut off that inlet and create a lagoon. That's a body of water that's sort of separate from the ocean. It may still be sort of salty because there's some water that sort of seeps between the bar or between the lagoon and the ocean, but it's somewhat separate. And then let me kind of walk you through some spits. We have different kinds of spits that are created by longshore drift. So this hook, you can if you can kind of imagine wave action is coming in, taking the sand and kind of spreading it down from left to right, and it creates that unusual thing called a hook as that sand continues to be spread down the beach, sort of parallel to the beach, building new land. So that hook is kind of unusual. A baymouth bar, kind of similar case to what we looked at a minute ago when we were talking about Bar Lagoon, where you have a really big area. There's some baymouth bars up in Point Reyes north of San Francisco that are pretty well known, but where that longshore drift spreads the sand out and kind of covers over the mouth of a bay. We call that a baymouth bar. And then a tumbalo is where longshore drift allows sand to sort of connect with a rock like a sea stack or a small island. And they're kind of unusual as well. Here's a hook along the California coast, so you can just get this kind of a small one. But you can see the sand moving from right to left across this view. A baymouth bar. There's the kind of lagoon area right here and it's sort of been cut off a little bit by this longshore drift carrying the sand from right to left across this image. And a tumbalo, Charles Island tumbalo in Connecticut. And there's the tumbalo there, and all this material here is sort of connected over time by this longshore process of sand being transported. Also wanted to mention fjorded coastlines. These are places along the coastline in higher latitude locations like Alaska, and parts of New Zealand, and certainly parts of Norway, where glaciers main valley glaciers once existed in these valleys, and the main valley glaciers have long since disappeared, so they've melted away, but the channel has been sort of colonized by the ocean. The ocean has sort of followed the glacier. As the glaciers receded, the ocean has replaced the glacial ice and created these very deep U-shaped passageways called fjords. And I visited one fjord. It was pretty amazing in Norway that was more than 100 miles from the coastline, and so you're standing in kind of the middle of the country, and you're looking at aquatic vegetation that you would see in the ocean. So they're pretty unusual. Show you some fjords in Alaska. Again, these blue areas here, the white areas are snow and ice. The red areas would show vegetation, but these blue areas here show the former pathways of main valley glaciers. You can see a few of the glaciers are still there. And in fact, if you go up Tracy Arm Fjord in Alaska, it terminates at the toe of a glacier. So this glacier at one time was much bigger and filled up this whole valley, but today it's receded back up into this point. And it's easy to get a cruise ship up into these fjords because they're very deep. Sometimes even submarines will I know the Russian submarines will sometimes like to travel up these fjords in countries like Norway, and making the Norwegian Navy very unhappy. To show you how far the Tracy Arm extends, the fjord is the ocean area, the blue area, and you sort of follow up here on the left-hand side of the slide and across the top of the slide, and then again you see the end of that South Sawyer glacier that we saw in the previous photo. Finally, I wanted to mention coral coasts. This is where this animal coral grows along the edge of islands and also continents as big as Australia, and creates a kind of a unique coastline. to show you what it looks like. This is a view. If maybe some of you have been swimming, you've had a chance to do some scuba diving or snorkeling down in coral, and you can see the amazing colors. But coral is a living animal that is sort of stationary and attached to usually a dead coral or rock. For coral to grow, you've got to have some specific environmental conditions. You have to have a temperature range that's really not too hot or too cold, clear, transparent water, and little or no sedimentation for coral to grow. And here's sort of a kind of a succession of what happens with coral formation in some islands, and including islands that you find in the Pacific. So imagine that a new island is born. So let's say you have a brand new volcanic island. A volcano makes an island like one of the, islands in the Hawaiian island chain. So you have a brand new island, and coral begins to form almost immediately around that island. So the lighter color here would be this sort of a side view here and kind of an oblique view of the island, but coral begins to grow all the way around the island and continues to grow. So over time, that island begins to be eroded away. In the middle example here, some of the mass of that island is removed through this normal weathering and erosion process, and the coral's still there. And you have what's called what's left is a barrier reef and perhaps a lagoon between the edge of where that coral is located and the island itself. This is in the case of Bermuda. There's an island off the coast of North Carolina, pretty well-known vacation spot. Bermuda has a barrier reef all the way around it. Pretty famous place. And then eventually the island may disappear entirely. No island left. And the only thing that's left is the ring of coral that's still there. We call that an atoll. So an atoll is like an island, but entirely made of coral. There may be some sand that's there. In a few cases, the U.S. military has actually put airfields on atolls. They're big enough for that. But here's a map that shows atolls as those orange dots. Red dots show areas with fringing reefs, and then the green dots show barrier reefs. And you see quite a bit of coral formation and the reef formation in the Caribbean, but also in South Asia and also in the Indian Ocean.